Hi viewers, welcome to this video on Cramer's rule. We are going to solve this system of linear equations with three unknowns. And just like I said in the previous video, Cramer's rule works when the number of equations are equal to the number of unknowns. So here we have three equations forming a system of equations and three unknowns that are x, y, and z. Okay, so first step is we write 1, 1, 1, 1, 1, negative 1, 1, negative 1, 2. So that is our matrix A. I said we must extract the matrix from this system of equations, and then we have our second matrix A sub 1, which is going to be a matrix that is formed when the first column here is replaced perfectly by these numbers here. So we have 3, 1, 2, then other columns remain intact, don't change, 1, negative 1, 2, right? So A sub 2 will be equal to the second column here is going to be replaced by these numbers. So we have 1, 1, 1, 3, 1, 2, 1, negative 1, 2. Right. So the third matrix here, A sub 3, is going to be equal to this matrix, but the third column to be replaced perfectly by these numbers. So we have 1, 1, 1, 1, 1, negative 1, 3, 1, 2. Okay, so that's the first step, right? We are confronted with a 3 by 3 matrix, so the manner in which we determine the value of the determinants for the four matrices is going to be different from the method we invoke when we are having 2 by 2 matrix, right? So we can now go and evaluate the determinants. So determinant of the first matrix, determinant of A, is we are going to take the first element here. This is the cofactor method, and then we take the determinant when we block this column and that column. So we're going to have 1, negative 1, negative 1, 2. Then because we usually have plus, minus, plus, so we have a minus, a 1. Then we have 1, negative 1, 1, 2. That is a cofactor when we block the the second column as far as the first number in the second column is concerned. So we block the first row, second column, and this is what we're going to have: 1, negative 1, 1, 2. That's what we have here. Then finally take positive 1, this positive 1, and we block the first row, third column. So we're going to have 1, 1, 1, negative 1. And so these vertical bars here represent determinant. So we're going to get the determinant of these 2 by 2 matrices extracted from the main matrix here. So the determinant of the first one is a 1, so 1 times 1 is 1, minus, this times that is 2, 2 minus 1, that's a 3, so 1, 3 plus 1, negative 1 minus 2, let's get a minus 2 there, right? So this gives me 1 minus 3, minus 2, and this gives me minus 4. So that's the determinant of the first matrix. Alright, so we go to determinant now of A sub 1. So determinant of A sub 1, we're going to take the first element, then proceed using the cofactors. So we block the first row, first column, and we are going to have 1, negative 1, negative 1, 2. Then we have plus, minus, plus. So as we write the second element, we're going to have a minus 1. Then the matrix, which is 2 by 2, when we block the first row, second column, we are going to have 1, negative 1, 2, 2, then plus 1. Then we have the determinant when we block the first row, third column, we're going to have 1, 1, 2, negative 1. So evaluating for determinants, we're going to have 3 times 1 minus 1 times, this is 2 minus 2, that's a 4, plus 1 minus 1 minus 2, that's minus 3, and so this gives me we have 3 minus 4 minus 3, which is just beta 4. Alright, so we evaluate determinant of a sub 2. Determinant of a sub 2 is equal to, when we write the first element in the first column and the first row, then we get the cofactors. We have 1 minus 1, 2, 2, then we have minus 3, 1 minus 1, 1, 2, plus 1, 1, 1, 1, 2. When we block the first row, third column, we get that. So this gives me 1 times the determinant, which is 4, then minus 3, then the determinant is 2 minus 1, that's a 3, then we have plus 1 into 2 minus 1, that's 1. So this gives me minus 4 once again. Alright, we're almost there. So determinant of the matrix A sub 3 is going to be, we have 1, then 1, 1, negative 1, 2, minus 1, 1, 1, 1, 2. What is when we block the first row, second column, and then eventually we have plus 3, then blocking the first row, third column, we have 1, 1, 1, negative 1, and so this gives me 3 times 1, so that's 3, minus 2 minus 1, that's 1 times 1, 1, plus 3 times minus 1 minus 1, so that gives me minus 2, so this gives me negative 4. Good. So we have come up here, we have now to solve for x, we need to take determinant of a sub 1 over determinant of a. To get y, we shall get determinant of a sub 2 divided by determinant of a, and to get z, we are going to have determinant of a sub 3 divided by determinant of a, right? So determinant of a sub 1, a sub 2, a sub 3 are all negative 4, so we get negative 4 over determinant of a, which was also negative 4, so perfect. Here we have minus 4 over minus 4, minus 4 over minus 4. Seems like we have a 1, here 1, 1. So the values of x are x, y, and z are 1, y is equals to 1, and z equals to 1. Okay, so we can perfectly confirm whether they are working in our system of equations. So we have x equals to 1, so 1, y equals to 1, 1, z equals to 1. So when we are adding them, we have 1 plus 1 plus 1, that's 3. Okay, we check the second equation. We have 1 plus 1 minus 1, that's 2 plus minus 1, that's a 1. Then we have 1 minus 1 for the third one. 1 minus 1, that's 0, plus 2 times 1, that's a 2. That's all true. So the values of x, y, and z are 1, 1, and 1 respectively. Thank you.